Okay, hello, good afternoon to everyone. Welcome to our next episode for the UNESCO Chair in Disaster Risk Reduction and Resilience Engineering webinars. This is a rather special occasion and episode in my view. My name is Yasemin Didem Aktaş. I am the co-chair of this particular UNESCO Chair. And today we are here to listen to Professor Virginia Murray and Professor John Rees on the UNDRR-ISC Hazard Information Profiles 2025 update. Next slide, please. Next slide, please. Yes, thank you. So Professor Virginia Murray is a public health doctor working currently as head of global disaster risk reduction for UK Health Security Agency. And Professor John Rees is ex-British Geological Survey, and he was the UK General Research Council's risk reduction champion as part of the Natural Hazards Team Leader at the Natural Environment Research Council. Next slide, please. I would also like to take this opportunity to tell you about our next webinar before leaving the floor to Virginia and John. On the 27th of November, we are going to be joined by Professor Saini Young for a talk on transportation infrastructure risk assessment on the context of climate change. As you can see here, it is going to be held between 11 and 1 p.m. UK time, and you can, as always, register for our event using the link that we share on our website. With this, and with much gratitude and happiness, I would like to leave the floor to Professor Virginia Murray and John Rees, please. Thank you.
Yes, May, what a delight it is to be working with you again. And what a privilege it is for us to be trying to share our talk with you. And it's just amazing to be working with Dina as well from UNESCO, because this is so much the work that we have been trying to do with so many of our wonderful UN partners, for which I thank you all so much. This is going to be a talk that both John and I are much involved with, but it actually reflects so many others who contributed, who have done so much to try and help us to update the UN Office of Disaster Risk Reduction and the International Science Council Hazard Information Profiles for 2025. So it's a wonderful story to tell you, but we have to start with the fact that we need these information profiles rather badly. So let me just remind you that Jamaica has had a terrible time with Melissa, but so has so much of the Caribbean. It really has been the most frightening experience. And of course, Jamaica is still very anxious about what's been happening to some of their towns where they really have been so damaged by this awful hurricane. But it's not just them that's had the problems, as you might know at the same time, even today. And yesterday, the impact from a typhoon on the Philippines has been enormous, and the numbers have been growing of those who've been very sadly killed, but also those hurt. But even in the UK, we've had a landslide. This was a landslide that happened early on Monday morning, where a train got damaged and had to stop and came off the track. And quite a few people have fortunately got away with minor injuries, but it was really important that this is not just happening around the rest of the world, it happens here too. But of course, if you turn to other landslides, in Uganda and Kenya, they have been having a terrible time very recently. They've had the most appalling numbers, and the fear and concern for people's families has just been enormous. And we can't forget Afghanistan. At the weekend, they had a terrible earthquake yet again, and there were certainly 20 fatalities, but there may be more. They reported that they had over 945 injured people. So very, very difficult for them. But even in Australia, they had these giant hailstones, which caused injuries to quite a few people, quite a lot of damage, and of course damage to homes, cars across southeast Queensland. So life is a bit complicated at the moment. And this morning, overnight, there was a blaze in Bosnia-Herzegovina where there was a retirement home which resulted in the deaths of at least 11 people. But there's also been something pretty shocking that happened this morning in Kentucky. An airplane took off, very heavily fuel laden to be able to fly onto Hawaii. And unfortunately, it hit a couple of industries, and there's been a major fire, as you can see from the airport in Kentucky. So things are happening everywhere, many of them completely unexpected, and many of them very frightening and shocking. But we need to remember something else today. Today is the World Tsunami Awareness Day. It is something that has been going on for 10 years. And of course, after the 2004 tsunami, there's been so much work thinking about what needs to be done. And to me, every 5th of November is a really important day because of this. And I am very glad to see that so much thinking has been going on about tsunamis and how we can do better. So let me remind everyone about the UN landmark agreements, an incredibly rich outcome for 2015. The Sendai Framework was agreed, the Paris Agreement, and the Sustainable Development Goals. What a powerful trio that we hope that we can implement. And the United Nations, of course, with its incredible leadership, has been so important in taking this forward. And that is something that we should celebrate, but also understand how we can do it. The Sendai Framework for Disaster Risk Reduction, as you will all know who are online, is really important to us all. It gave us a clear global outcome, 13 guiding principles, including linking to human rights and indeed to science, which is of course so important for UNESCO. It brought 4 priorities of action absolutely to the forefront: understanding risk, governance, investing, and how to build back better to recover from these events. And it was a really powerfully agreed framework, which was adopted by all UN member states, finally at the UN General Assembly in the summer of 2015. But in it, there were 7 global targets and 38 indicators. An incredibly important group of indicators and targets because they were about reducing mortality, affected people, economic loss, and damage to critical infrastructure and disruption of basic services. And we know that COVID has hit them very badly, but we need to know that we must move forward by increasing our knowledge of each country's hazards and how we can develop local and national disaster risk reduction strategies. How we can build that wonderful thing of international cooperation, which is part of the work that we're doing here today. But we also know that we need the availability and access to multi-hazard early warning systems and disaster risk information and awareness, and that's coming through so strongly, as we'll share with you later. Now, the Sendai Framework, because I was the vice chair of the Sendai Framework Science and Technical Advisory Group, was something I sat in all the time. And so I became, as usual, a bit of a nerd, and I painted in yellow all the bits that had science, just in 3 pages, to see if we brought a lot of science and a lot of health to it. So this is just 1 page, a second, and a third, just to show you that science is at the heart of it. Dina, isn't that exciting that we've really managed to engage to get so many people to feel that this is something that's really going to make a difference to all? But then we have to think about how we're going to take this forward. And one of the requests was that the conference recommended that the working group consider the recommendations of the UN and United Nations Office for Disaster Risk Reduction Scientific and Technical Advisory Group, which we had recommended, was to update the publication entitled the 2009 UN-ISDR Terminology on Disaster Risk Reduction by 2016, and that it should be submitted to the Assembly for its consideration and adoption. A pretty brave request on our behalf, but I'm delighted to say that we did deliver it. This is the report of the open-ended intergovernmental expert working group on indicators and terminology relating to disaster risk reduction, and you'll notice it's translated into the relevant languages by the UN of Arabic, Chinese, English, French, Russian, and Spanish. So to try and make it as useful, usable, and used as we could. And the report is here in detail if anybody wants to look at it, because it was an incredible opportunity for us all to work together with so many scientists and organizations across the world. And we thought we did rather well. We thought we did really actually very well. We defined a hazard. A hazard as a process, phenomenon, or human activity that may cause loss of life, injury, or other health impacts, property damage, social and economic disruption, or environmental degradation. And then we put in a whole series of annotations that came in with it as well. And we thought we had really mastered what was needed to understand what a hazard is. Okay, so this was adopted by the General Assembly in February 2017, having delivered it by December 2016, a huge achievement. And then we started moving towards UNDRR implementing its monitoring framework with custom targets and indicators. And it was in 2018 when I was at the technical forum leveraging the Sendai framework monitor process that there was a bit of a hiccup. A lot of the countries really were struggling with it. They were reporting, many of them, and we had about 80 different UN member states present at this meeting, on the numbers of deaths, the numbers affected, and other information that was going to be important to add to the Sendai Framework Monitor. But everybody was struggling with it. And it wasn't until towards the end that we realized that our definitions that were listed under UNDRR terminology didn't really do the trick. And I was at the 4th Global Summit, this time in Japan in March 2019, when suddenly somebody asked me if I would be good enough to take a role in chairing a group that might take forward this understanding of what all hazards means. So I went back to the Sendai framework with so many others did with us, and it was all about strengthening technical and scientific capacity to capitalize on and consolidate existing knowledge and to develop and apply methodologies and models to assess disaster risks, vulnerabilities, and exposure to all hazards. A huge challenge. We needed to find out what was known, what we didn't need to do, what we did need to do, and how we could work together. And yet again, UNDRR came up with a wonderful solution. The United Nations have had a plan of action on disaster risk reduction for resilience since 2013, which was updated in 2016, and they've published a further report in 2025 of how it's being implemented. But just to share with you, we used the 2016 report, which had approximately 60 different UN agencies and organizations as partners. And one of the things that UNDRR has been so strong in doing is to have a monthly meeting with anybody who's available to try and pull together to see what we could do to build what was needed for disaster risk reduction for resilience. But by using that incredible network, we were able to move forward to looking at how we could think about delivering a UNDRR International Science Council Hazard Definition and Classification Review, a technical report for July 2020 after the request I received in March 2019. So to do this, we brought together friends, amazing colleagues, and I will share a list of some of them. But we brought in UN agencies and organizations, including the World Meteorological Organization, the World Health Organization, the Food and Agriculture Organization, and of course, UNESCO, DINA, and many others. There were so many others involved in this. But we couldn't do it without our scientists. So the International Science Council, of which I'm a fellow, volunteered to include many of our networks, including Integrated Research on Disaster Risk, Committee on Data, GEO, GEM, and many others. But it was a very strong request that we must also work with the industrial science partners, and the Insurance Development Forum was a way of pulling together the insurance industry. But for me, I feel, as so many of others on the steering group, that we needed to have really frontline representation, and the International Federation of the Red Cross, Red Crescent said that they would join our steering group as well. So we had many volunteers, and we reached out to many. What a privilege. So who did we have on our steering group? You can see the shopping list is long, and you'll notice that I have the privilege of chairing it. Then we were called Public Health England, but we're now called UK Health Security Agency. But we can see the wonderful network of really good friends who were so skilled and wonderful in working with us. And John was part of the team, because that was vital that we had all the different skills that we needed to be able to bring together across the world the things that we needed to be able to understand how we could do this work. Now, one of the first calls was, what do we know? So we turned to people like David Alexander from UCL and said, David, do you have a shopping list of all the scientific lists, all the scientific glossaries? And David shared a big shopping list. And you can see the numbers of the different glossaries by themes. We had over 623. And then there were 391 on climate change, and there was governance and water, and then there were lots of glossaries by the different types of hazards, even in themselves. And it was working with Lydia Maynard that I was so privileged that she and I went through these, and we really worked hard to try and consolidate these. So I'm just showing you 2 screenshots of some of the different types of glossaries that we turned to and looked at and reviewed and brought together to see how we could understand it, with probably about 10 pages in between. You can see that it was a complicated task and quite an engaging one. But scientific glossaries do not answer everything. So we turned in our next annex to our wonderful UN funds, programs and specialized agencies and others from UNDRR. And again, working with Lydia, she and I worked really hard to pull together the whole series that we could find from this network. And you will see that we've got FAO there, we've got the International Atomic Energy Agency, we've got International Labour Organization, International Maritime Organization, International Organization of Migration, ITU, so many others, UNAIDS, United Nations Convention on Global Desertification, through to the United Nations Development Programme, to UNECE, who've been absolutely incredible. They are really good at definitions, very proud to work with them, partly because of their statistical engagement, but also the UN Environment Programme, UNESCAP, linking to others like the UNFCCC, UN Habitat, UNHCR. You can see so many of these groups were absolutely key to us thinking, even things like trying to see about the UN Office for Outer Space Affairs. That was very important if we were going to include extraterrestrial hazards, but also the United Nations University. They didn't have a glossary, but they did have quite a lot of things to share with us, which was wonderful. UN Women, the World Food Programme, WHO, my gosh, WHO, they've been brilliant. But so is the World Bank Group and UNFCCC. We pulled all these together, and I can tell you that then there was an awful lot to think about. So what hazards should we include, and what would be our criteria for including them? So here are the discussions that developed, which ended up with the following inclusion criteria. The hazard has the potential to impact on a community. There are proactive and reactive measures available that we can manage on how we can understand what to do. And the hazard has measurable spatial and temporal components. These were the 3 really important inclusion criteria we used to help drive our decision making. So the next stage was to build consensus. And this is shared in our report, but it's very clear that the consensus building was absolutely critical to see how we could bring all together the regional science and technology advisory groups that work under UNDRR for the science and technical advisory groups, but with so many others. And we used an online survey. We tried to engage with so many others around the world to make sure that what we were doing was actually going to be helpful to many. And we ended up by having our description of the hazard clusters. I just show you here very briefly 4 of the clusters to show you that we included those. But in the end, we had 8 hazard types. And these were the hazard types that we thought were really important to include. And they're beginning to emerge in this image about how we tried to pull them together. And then we looked at the scientific description of each individual hazard. Should we have photographs? Should we have diagrams? How can we do it? How can we make it more interesting? How can we engage people? And there was a lot of discussion, and we knew that we couldn't have photographs, because if you had a photograph of an earthquake impact, for instance, in Algeria, what would you do if you had an earthquake in Afghanistan? And people felt that you couldn't do it because you suggested there was only one place that earthquakes occurred. So that didn't come into it. But what we did end up is that we would have a primary definition, something as clear and as crystal as we could make it, preferably using the highest level within the UN that would recognize that definition so the UN member states could really feel they could buy into it. We would have a scientific definition. We'd have the metrics, the numerical limits and DeFi guidelines wherever we could find them at a global level and occasionally at a regional level if we couldn't get the global level. And then we'd have the relevant key UN conventions, regional conventions, and multilateral treaties if needed. And then we'd have essential annotations such as drivers, outcomes, and risk management. And then we would agree which of the UN agencies or scientific organizations would hold the responsibility for updating all this work. Now, all of this we felt had to be open access with relevant references, hyperlinks, and websites to use. So we hoped this would be really clear. And then we thought we must make sure we reflect users. And we really needed the user-driven classifications that were really going to make something that would work at a local level, but also at a national or regional or global level. So we needed these faceted searches, the way of engaging that would really make it much more alive. And after that, we knew that we had to think of our potential applications. Was it going to be of use at national and global level? Were we really finding the answers that were needed for UNDRR and the UN member states to take this forward? And we think that that's something that's really important because cataloguing loss and damage is becoming even more critical as we move forward. And lots of exciting developments have heard recently. So constantly we were looking at really challenging ourselves to think about the complex, wicked challenges. We also knew we needed to plan for the multi-hazard early warning systems that came in 2022, which was something that was incredible. We'll mention it again later. And we needed to strengthen that vital science policy interface that UNESCO and so many other partners have really brought together for us as a key understanding of what we needed to do. So we summarized this in this slightly more simple and elegant one figure diagram of all the things we wanted to do, looking at definitions, how we needed to expand them, what we did for searches, how we consulted with others, how we did surveys of scientists, how we had our inclusion criteria, our hazard lists, and then our recommendations, building towards a dialogue of a more holistic, consistent approach to hazards identification and definition. Wow! So what did we get? 302 hazards. Why 302? Well, I didn't know, but equally, it still remains an interesting challenge. So you can see we have the hydrometeorological, the extraterrestrial, the geological, the environmental, the chemical, the biological, the technological, and for completeness and with great thanks, we were allowed to include societal, although they're not part of the Sendai framework. Really important for us to think this through. So the next step was to have our hazard information profiles prepared. And you can see that then we built another diagram identifying subject matter authors, getting a hazard information profile written by the subject matter author, then getting it reviewed by subject matter experts not involved in writing the original document, having an iterative development process, and finally, because I was chair, getting each of the hazard information profiles signed off. I must admit, a lot of reading, a lot of thinking, and a lot of discussion. So what did they look like? This is drought. And you'll see we've got meteorological, hydrological drought, agricultural drought, and even socioeconomic drought included. We're quite pleased with that one. Near Earth objects, we were very concerned about those. And of course, tsunamis. Remembering today is Tsunami Day? Well, really important, but incredible definitions from the International Oceanographic Commission about travel time, arrival time, really good material that UNESCO and colleagues provided. And then, of course, coastal erosion and shoreline change, which you'll notice here that this is not a UN definition. This comes from a scientific report, and where we got stuck, we would turn to these. And oil pollution, a big issue. So we had that there. And human-wildlife conflict, very important. So the International Union for Conservation of Nature became really important to us. And dam failure. This time we moved to the International Commission on Large Dams, which is not a UN organization, but a wonderful engineering organization. And for completeness, we thought it was really important to financial shock. And we were really glad to have this included from the European Central Bank, although it links very much to the international, to IMF, International Monetary Fund. So it gives you a flavour of the range of all the things we had to think about. But what we knew was that we needed regular review and update, and to use the hazard list to actively engage policymakers and scientists and to address cascading complex hazards and risks. But what we loved was this message that the UNDRR wrote for us. I didn't write it, but they pulled together how we could link with the Sendai Framework, the Sustainable Development Goals, and the Paris Agreement by providing a common set of hazard definitions for monitoring and reviewing implementation, which calls for a data revolution, rigorous accountability mechanisms, and renewed global partnerships, which I think are vital. So this is what we delivered. And then we come to the Sendai Framework midterm review. And they just said it was groundbreaking. It was so exciting that we had delivered something that was thought to be really needed and really helpful. So really thrilling for us who'd all been working on it with our 800 partners and scientific institutions and national science advisors and research funding community and numerous international organizations. We thank you all. So grateful. And of course, this links to the early warning, and it links to the wonderful disaster loss and damage tracking system that UNDRR are now using under Delta, the Delta Resilience Disaster and Hazardous Events Loss and Damage Tracking and an Analysis System, which is really coming online and only last week was being launched in the Pacific. Amazing work. And in the heart of it, it was all talking about ensuring data standards. Isn't that great? And there you see our work right at the heart of those data standards. Really stunning news. We were delivering something that we hope would be useful, usable, and used by many, linking to WHO, linking to the UN Statistical Commission, linking to the technical reports on guidance to member states, everything that we could possibly do. And then in 2023, the request went out. We ought to review the hazard information profiles ahead of the 2025 global platform. And our objectives were to review these, make sure that they reflected the needs of users, and to increase the breadth of awareness and of the existing hazard information profiles and their use. So this is the next step. Again, we have our wonderful network of friends, and this was the steering group this time. And I really wanted, besides saying thank you, John, yet again, and your wonderful colleague, Julia Crummy, for all the geological hazards work, but to thank amazing project manager from the International Science Council, Hélène Jacob-Decombe, who really has been amazing in helping us to deliver this round of the hazard information profiles. But you can see our wonderful colleagues from around the world and what an incredible support mechanism we had to try and deliver this along with many others. So thank you all. But to do this, we had to start with a survey. Were we doing anything useful? Is there anything we could make better? And we were really thrilled when at least 75 of those who responded did say that we were delivering something that would be clear and helpful, and that the feedback was user-friendly, harmonized, easy to navigate, straightforward, standardized. We got so excited, and then they suggested we needed to improve interoperability with IT system simplification, and suggestions that section within each profile may need to be separated out. They were absolutely right. But we also knew that we needed feedback. Can we make it better for early warning systems? Is there multi-hazard? Should there be graphics? Should there be cascading hazards? And then we got information on procedures, forecasting, visual aids, IT compatibility, complex and multi-hazard again. And these were the sorts of hazards that they thought we should be thinking about including as well. So some of them we have, some of them haven't quite passed our test for inclusion, which has been really interesting. For instance, marine heat wave has. Opiates have. And we asked people to give us quotes on what they thought was useful. And this is perhaps my very favorite, so I'm going to share this carefully with you. The HIPs offered are valuable resources that contribute to effective DRR. The profiles offered detailed insights into various hazards, aiding risk assessment, preparedness planning, and resource allocation. By enhancing community awareness, supporting policy formulation, they serve as crucial tools for informed decision-making. They play a vital role in my work, engaging communities, guiding policymakers, and assisting emergency responders during disaster events. Additionally, hazard information profiles contribute to monitoring and evaluating the effectiveness of risk reduction measures, fostering a proactive and resilient approach to managing the impacts of natural hazards at local, national, and international levels. The most wonderful quote. I can't tell you how delighted we were. And this was somebody we didn't know who was a respondent based in a national disaster management office in the Pacific. I thought this, and along with the others, we felt that the HIPs were serving a useful, usable, and used approach. So I was really grateful to this report. So the next step, let's go again. So off we went again with wonderful Helen. And most importantly, we divided them into different groups of our technical team members. And John will demonstrate to you what a geological technical team did. But we also knew we needed a user group. We need a multi-hazard context group, and we need a machine actionability group. So I'll share with you some of the outcomes from these. And I just wanted to remind you that Myriad European Union Consortium, because I had the privilege of being on their advisory board, were amazing in supporting this work. So there are many of those, along with many other multi-hazard people who've been just superb. So we now have gone down to 281. Haven't we done well? Trying to reduce it from 302. So it's reduced and clearer and more useful. So we have the hydrometeorological, we have the extraterrestrial, we have the chemical, the biological, the technological, the environmental, the geological, and still the societal. So we'll take you through those. But for each revision, in our 8 working teams and additional groups, we had more than 200 expert contributors. We had more than 100 experts and users who reviewed, and then we had the technical teams review and address and really sharpen from all the wonderful comments we got back. Really amazing work. But we also worked really hard on the multi-hazard context. So we've got the triggering hazards, the hazard itself, and the triggered hazard. So this is the parent of the hazard, and this is the child of the hazard. And we used colored boxes and all sorts of ways of trying to share this, and we'll show you in a moment. So we also have this, which describes very clearly what each hazard is and what it contains. And you can see there's very clear information for each of the different sections. And now I'm going to hand over to you, John, so you can take us through the geological hazards. Thank you.
Thanks, Virginia, and thank you all for coming to this, and welcome to this. First of all, what I want to do is really say something about how we put the geological hazards together. What you see on the right-hand side of the diagram are the geological hazards which are contained in the latest iteration of the HIPs, and you'll see that they come under 4 classes: seismic, volcanic, ground failure, and other. Next slide, please. To look at these and review these, we've brought together a geological HIP review team, which I led with Julia Crummy, my colleague at the British Geological Survey, under the guidance of Virginia, who is looking at the overarching structure of the HIPs. And you can see here the geological HIP team, and you'll notice that people have come from a very wide range of organisations. And they've got a good balance of men and women on the team, a good range of nationalities and specialisms. Next slide, please. What we did was we looked at the first set of HIPs, and we asked for comments or commentaries from many users on the HIPs and any problems with them. And then we put these into tables, and we looked at basically where there were overlaps or gaps in the HIPs that we had in the first edition. This is a snapshot of some of those HIPs from a table we used at the time. And you can see that there are a couple of HIPs that we've got duplications for, and we started asking questions of ourselves about whether we needed to split or merge some of the hazards that had been defined in the first edition. Next slide, please. So the four groupings, the four clusters that we identified were seismic, that's earthquake related, volcanic, ground failure, and then other. Seismic is clearly where you've got deep earth processes which are causing the ground to move, and shifts of faults caused by plate movements largely is the main driver of the seismic hazards. Volcanoes clearly where you've got magma coming up to the near surface and often in eruption. Ground failure is where you have gravitational forces which are causing problems. And then other is a bit of a bucket, but contains things like soil-related processes, and I'll touch upon those later. Next slide, please. So when we brought this group together, this is we started putting the different hazards we had into these different clusters, and this is our first mapping of those. But what we recognised that there were some groups which are very large, such as if you look at ground failure, you have things like collapses, which are things like soil collapses and shallow hazards. But then you have others which are much more to do with one type of failure, for instance, a landslide. So what we had is kind of large groupings of multiple HIPs, which all fall under what we call a chapeau. Really is like an umbrella term. And what I'm going to illustrate for you today is how we handle that chapeau in relation to landslides, which is basically slope failures. Next slide, please. Oh, sorry, before we move on to that one, just to say that there were some hazards that were previously in the first iteration or the first edition of the HIPs, in the geological HIPs, that we decided probably were better to go into other HIPs, into other hazard areas, such as tsunami, lightning and fire, which we thought probably weren't best actually lodged under the geological HIPs. Next slide, please. So gravitational mass movements. These are what are commonly known as landslides, which isn't entirely accurate, and I'll explain why in a second. But they have a very big impact, as you might guess. You can see here a lovely picture of a landslide from Switzerland, and some very lucky people who have avoided being damaged by the landslide. Next slide, please. So this is what the HIP looks like. This is the front page, and could you zoom through the various pages we've got? You can see that this is showing the classification of landslides. Next slide. This is looking at drivers and impacts. Next slide. Then we have our multi-hazard context, which I'll explain a bit more about. And next slide. Then we have the references, and then finally we have the case of the coordinating agency or organisation. And what I'll do now over the next few slides is take you through this chapeau as an illustration of how we've structured the HIPs generally, as a general example, basically. Next slide, please. So first of all, this is the top of the HIP. The first thing we see is a definition. Clearly, there are many definitions associated with each of these events, and what the expert group and those other scientists, experts we've actually approached and asked, we've actually come down and boiled down to one hazard definition, if possible, and that's what you can see here. This is one by Cruden and Varnes. Gravitational mass movement in landslide is the downslope movement of soil, rocks, and organic materials under the effect of gravity, which occurs when the gravitational driving forces exceed the frictional resistance of the material resisting on the slope. Such movements may be terrestrial or submarine. That's the definition we've used for gravitational mass movement, generally known as landslide. And the reference is this one you can see at the bottom, Cruden and Varnes. Next slide, please. So we've also looked at synonyms. So landslide, mass movement, mass wasting, slip, slope failure. These are all terms that are used to refer to landslides. And we've also provided a bit of an additional scientific description, which explains a bit more than the definition about what the landslide actually means. And this covers actually what we call landslide. It covers many types of failure actually. And so you've got falls, you have spreads, you have rock avalanches, slides, and topples. You can see on the right-hand side, you can see there's quite a classification of these types of failure, both in rock and debris and earth. So rock is when you've got solid rock. Debris is where you've got components of that rock which kind of tumble and come down as semi-coherent parts. And earth is where it's almost like a soil or a mud. So you can have all these types of failure in those three different regimes. And this cartoon, which was produced by my organisation, is to help people understand where in this kind of a large area, a particular event that they're looking at, anyone's looking at, actually fits. Next slide, please. So just to say a bit more about these, a fall is where you have, as you can imagine, rock normally or soil just falling down, often a cliff or a slope. You can see a very nice picture there from southern England. A topple is where you've got a rock or element of sediment moving away from a slope, and you can see here a nice area of rock which is going to topple away. A slide is where you actually have a rock or sediment sliding down the slope laterally. Spread is where actually you've got this in very slow motion, and as a result you've got a slope where you've got fissuring in the middle of the slope. You can see that on the bottom left. A flow is where you've got sediment or rock, which it almost acts as a liquid in terms of how it moves across areas. You can see there's this flow of sand and mud, which has crossed the road in this case. And then you have complex events, and complex events are actually very common, where you've got almost all of these elements in one place. And that's a picture from Sierra Leone. You remember we had some very bad landslides there. Also, all of these can occur in terrestrial, that's subaerial, and submarine environments. Next slide, please. So just to say something about what triggers these, there are two main triggers of such gravitational mass movements. Firstly, earthquake triggered, and in fact, if you look at how to identify these, earthquake-induced gravitational mass movements are mostly located in steeper, longer slopes and have a higher position up on the slope. And this has been found in many places. And in fact, this is the case also in Wenchuan in China, very nicely demonstrated. In Wenchuan, China, there was a large earthquake, but over a third of all of the casualties, of 70,000 casualties, were caused by the landslides, and landslides coming down from both sides of the valley. And you can see the picture on the right, where you can see that landslides have engulfed many of the buildings at the bottom of the valley. Next slide. Another regime, we have a lot of landslides of volcanic triggered gravitational mass movements, which often are quite different. And what happens in these environments often is mobilized rock and sediment is often flows a long way away from the site of the initial eruption or the volcano. They're often common on volcanic cones, and the run-out lengths are often over many tens of kilometers. And you can see there's on the right-hand side the volcano Nevado del Ruiz, which erupted in 1985, and large amounts of the material erupted at the time from the volcano through passage of water down the slopes, etc., moved into river valleys and swamped large numbers of people, and many people were killed. And you'll find that if you look at volcanoes around the world, some of these runouts from volcanoes can extend for many hundreds of kilometers well away from the site of the eruption. So this is quite important to understand with some of these mass movements. Next slide, please. In terms of how we measure these, we look at volume, run-out distance, and the area of the disturbed ground, which is probably the most common. But you can also look at them in terms of the speed of flows. In places like Nevada de Ruiz, we're often talking about hours for material to move many kilometers. And in fact, in submarine environments, it can be even quicker. And in fact, in 1929, in the Grand Banks offshore Newfoundland, there was a big submarine landslide. If you look at the image on the bottom right, that pale blue area shows the limit of the extent of the landslide, covering several hundred square kilometers. And the speeds of transport of the sediments and the rocks down the downslope was up to 28 meters per second, or over 100 kilometers per hour. And this caused many secondary impacts, such as the cutting of submarine cables, which had just been recently installed, allowing North America to be connected to Europe in terms of telegraphs. And what's quite important with all of the HIPs is that we've highlighted in the key relevant UN conventions, and you can see that the Sendai framework is the key convention which covers these HIPs I'm describing here. Next slide. We also look at examples of hazard drivers, impacts, and risk management. With gravitational mass movement, I think it's quite important to say that the main drivers of these are earthquakes, volcanic activity, storms, precipitation, differential weathering, and human activity. It's also important to understand that, excuse me, you actually can have these occurring on slopes of many different angles. It's not only on steep slopes, but it can also be on some very shallow slopes. And you actually have landslides which can occur on slopes as shallow as 1.5 degrees. Just bear with me, I just have a quick cough. Thank you. At the bottom there, you see a landslide which has occurred in Scarborough in Yorkshire. There's a place called Holbeck Hall, where in fact the initiation of this landslide started occurring on very shallow slopes, but this is where it steepened up and went down to a beach area. Next slide, please. So the impacts, you have significant impacts. Over 30 years, the gravitational mass movements have affected over 4.8 million people and caused over 18,000 deaths. And I think these figures are quite conservative. And they also cause many secondary impacts. So one thing that, for instance, landslides often do is dam valleys or impound lakes, which causes secondary problems for people who are impacted by the landslides. Next slide, please. They also cause health impacts. The risk of increase in infectious disease is increased rapidly by having a landslide. And then some of the long-term effects of environmental long-term effects of landslides, such as deforestation or changing of river courses, can then increase the risk of vector-borne diseases. And the last one on this slide, which is very important to recognise, is that the psychological and mental health impacts on survivors and rescue personnel from mass movements are increasingly recorded. And I think this is pertinent for almost all hazards in HIPs, but it's definitely relevant in the case of landslides. Next slide, please. In terms of how we show these in the HIPs, both the drivers and the impacts, we have these multi-hazard context diagrams, which I think are really useful and helpful for people who are perhaps not familiar with the subjects we're talking about, which show many of the hazard drivers. So you can see them at the top there. So for instance, geological, you can see you've got the main drivers of gravitational mass movements are earthquakes, lava flows and domes, surface ruptures and falls, and soil degradation. And you can see that you've got the code of the individual HIPs underneath after each of the titles. You can see that you've not only got geological, but then you've got extraterrestrial, technological, environmental, and meteorological and hydrometrical. Meteorological and hydrological. So these are those things which drive landslides. But on the bottom part of the diagram, you can see the impacts, and you can see the same areas. And again, you can see some of the hazards which are driven largely by landslides. So, for instance, in the green one, you can see tsunamis are often generated by landslides. Next slide, please. So in terms of monitoring, we obviously these hazards are monitored all around the world. What we've done here is summarize the main organizations which actually do the monitoring. So it's often local authorities or geological surveys, but there are often many other groups who do it. And I think in future iterations of the group of the HIPs, it'd be really nice to start being discreet about which organizations do what. How hazards observed and monitored forecast. These days there's global monitoring of events as they occur, and what's increasingly important is that we're actually getting better at forecasting where landslides are likely to occur. So risk management. What we do in risk management, we look at two things. We're looking at active protections and passive protections. In the next slide, I'll show something about those. So inactive protections are where we're actually trying to prevent landslide, prevent movement occurring in the first place. So you can see that you've got general methods such as retaining walls, wire meshes, scaling or mining, or regrading slopes. And you can see on the right, you've got a regraded slope in the UK where we've got a railway line at the bottom of an embankment. Next slide, please. And now you have then passive protections, which are really where you're allowing material, the moving material, to bypass what you're trying to protect. So you can see on the bottom, on the right-hand side, you've got a tunnel in Switzerland, which allows rock material, soil material to flow down over the tunnel and therefore not disrupt the traffic, etc. You can actually also do something about trying to prevent material hitting your infrastructure or your roads, etc., through nets. For instance, you see here in Canada, which is actually stopping the movement of rock and debris down a gully onto the road. So you get these passive protections that largely consist of barriers and dikes, diverters, gullies, or protection galleries, fences, or wire meshes. Next slide, please. Last thing in the HIP is a large number of references. You can see here I've foreshortened the reference list just to show you the types of references we've got. And then a reminder of what the coordinating agency or organisation is. In this case, it's the BGS, the British Geological Survey, and the Geological Survey of Canada who've put really together this. But you'll note that in the geological HIPs, there's no owner of these HIPs at present. And this is something we perhaps need to do something about before the next iteration of the HIPs. Next slide, please. So I think that's given a good view of what's in one of the chapeaux of the geological HIPs, which is looks very much like the HIPs themselves. And this is to show something of the final hazard groupings that we used, the clusters we used in the end. So we've got seismic, volcanic, ground failure, and then we've got other. And you can see each of those bullet points bullets shows an individual HIP. And then we have the chapeau, which is another HIP in itself, which is the one I've just illustrated. So I hope that gives you a good picture about how we've put these together. And what we've done in the geological HIPs has been really reproduced in the other HIP areas as well. Thank you.
John, what an incredible summary. I think it's really important to see how much we can put on to 4.5, 5 pages to make it as brief and as sharp and as clear as possible. And thank you to all the geological team. I know you had over 50 people working on this from around the world. It was a great achievement to review the hazards that were included in the geological groupings, but also the working across the whole of all the others to see where the hazards might fit better, such as moving the tsunami out of the geological hazards into the hydrometeorological ones. So very interesting how it came together. So let me just move on and just take you to another type of hazard, which we thought would be really important to share because this is particularly engineering focused, this UNESCO talk. So I'm taking you to the technological hazards, which I know you and many others were much involved with. And here we have the cyber hazards. So the International Telecommunication Union were really involved in so much of this. But then you have the construction and structural failure hazards. And these are the ones that we've had a lot of engagement with, but maybe people who are on this call might want to help us to make them stronger for next time. And then we have industrial failures of leaks and spills and soil pollution and explosions, fires and general pollution, mining hazards, safety from oil and gas extraction. But also we've got industrial failures through NATEC. And we've had huge support from the European Commission and the Disaster Risk Management Knowledge Centre for all that work. But there are also the transportation accidents there and the waste accidents, the waste hazards, which have been increasingly important, and different bits have been completed by different networks. So the waste treatment lagoons are particularly by FAO, but the electronic waste, funnily enough, comes under WHO. So everybody's been involved in different things, and we finally included radiation in this group. But I thought I would turn to one particular example about tunnels. Now, tunnels weren't in the first group, and after a lot of discussion, we felt it would be important to include tunnels as an engineering issue this time. So we went to the most wonderful group, the International Tunnelling and Underground Space Association, and to the president and their colleagues who contributed so much to building this hazard information profile on tunnel failures, following exactly the same way that you've described for the mass movement landslide hazard. You can see that we have a definition, we have synonyms, and there are plenty there, although we do have others that have had so many synonyms we had to add an extra feature for it. But we also have the additional scientific description and the types of tunnels, which I thought was really fascinating, because I don't think we necessarily all thought of these types of tunnels. There was a lot of discussion about the metrics, how they might be thought of, and then under the key relevant UN Convention multilateral treaties or frameworks, you can see that we have two here, but most of them are actually European related, which was really interesting. Again, hazard drivers, again impacts, and again the multi-hazard context. Using geological earthquake, of course, is a very closely related issue for tunnels, but so are things like explosions, fires, rail accidents, road traffic accidents in tunnels being really significant issues, and indeed hydrometeorological issues such as tsunamis. These can all lead to a tunnel failure, but the outcome can be leaks, spills, pollution, rail accidents, and road traffic accidents. So it comes back to what goes through the tunnel, what will happen. The monitoring is not so clearly detailed as you had in yours, John, but it's still something that is really important. And I think what startled me was the incredible life cycle of so many of the structures, and indeed the instrumentation and sensors that are used to combine the data analysis. That struck me as such a rich resource of continuous monitoring of structures, which includes tunnels, but also bridges, dams, and other buildings. And this allows for making timely, informed decisions about when the integrity, the structural defects might be determined, predicted, or estimated, and seeing what the life of these different engineering issues might be. So I was really excited by that, and I thought that was a really brilliant summary, albeit incredibly brief for the amount of work that goes on. And then the risk management. I thought the summary that we got from our colleagues was really good, and I was really pleased to see the Code of Practice of Risk Management on Tunnel Works that it came through in 2023 and its implementation, and the information about how we could look to the future. And again, we had references. What was so wonderful is these are open source, open access references. So they fit very much with UNESCO's request for open science, an incredibly powerful resource that we thought was really magical. And you can see how we go through and bring this together. And again, this time we have as a coordinating agency or organization, the International Tunneling and Underground Space Association. Thank you, ITER. Thank you so much for all your engagement. And what a great example it is of engineering collaboration in trying to produce something that we thought was really clear and hopefully very useful. Now, just to remind you, of course, today is Tsunami Day, so I would include that as a hydrometeorological hazard. And you can see we're color coding all these different types of hazards all the time to try and make it easier for everybody to see. and that we have space debris. This is the new one that's come into the extraterrestrial one this time, very much at the request of so much of the UN concern, with the Committee of the Peaceful Use of Outer Space, and indeed the UN Office of Outer Space Affairs. But it was the UN Environment Agency, Environment Programme that was so keen that we should include it. So the really important work there, and I'm very pleased we have it. Your earthquake is there. I think it's a really clear one. It was very helpful, John. Thank you and your colleagues. But we've got things like loss of mangroves, something that really worries me if we don't sort out the loss of mangroves around the world. And that's been something that's been incredible that one of our young scientists really provided us with an update on yet again. So a wonderful colleague of ours who's based in the Netherlands at the moment from Indonesia. And the Global Mangroves Watch was something that I was really excited to learn more about. But then the corrosive substances, as something that somebody who's worked as a medical toxicologist, we know this is such an important problem. And there was so much discussion about how we should include this best, and to include the GHS classification of UNDRR-ISC, which was so important for us to all know about. And foodborne diseases, such a critical impact. And here we've managed to turn them into bacterial, viral, chemical, radiological, all the different types of hazards are included here. Isn't that exciting? We can pull it together to make a full story if there isn't a better home for these individual hazards. And of course, you have to have building collapse. Think of what happened in Italy only on Monday, where a tower fell down and somebody very sadly died and somebody else was hurt. But what is so interesting that this time it's the US Department of Labor that provides the definition, because there doesn't appear to be a UN-related definition. Important. But we do have lots of links to the International Labour Organization, who have some of the issues there. And then something that is really important is environmental degradation from conflict, something that we are seeing around the world that's caused us so much anxiety. And we know that we'll be hugely involved in trying to rectify this one way and another. So what are the outcomes of this 2025 update? Well, let me just share with you where we should go next, because we know that this should be updated. It's really vital. We hope it'll fit for every global platform, and we hope that many of you will want to come and join us if you can. So the first thing, we must do this regular review and update of the classification and of each of the hazard information profiles. Is it right? Can we do it better? Will we make it easier for you all to be able to manage it? Can we improve the information on the multi-hazard context? How will this work? We've never done these diagrams like this before. And with Hélène Jacob de Com's huge leadership, this is what we came up with all our multi-hazard context partners. It would be amazing if you can think about it and see if we can make it stronger. We know we need to engage with users and of all the stakeholders on how we do this. We really need your help. Can you teach us how we can do this better? Can we engage further? Can we do something that will make a difference? Can we make sure they're really useful, usable, and used? And how do we make the use and usability of HIPs in databases and information systems more expanded? Well, we have some ideas, which I'll show you in a moment. But if you have any ideas, we'd love to know, wouldn't we, John? And we want to link the HIPs to other global development frameworks and decision-making processes. Do they provide the resources that are needed to really make sure that we can all talk to each other from the same system? And can we complement the HIPs with other developments of definitions and standardization, maybe for exposure, but particularly for vulnerability? Should we be looking at vulnerability information profiles? Is this something that UNESCO would find helpful? Can we think about this? We'd love your help, Dina, to think this through. I'm glad to say that they are all online. You can go in there and get them. But is that enough? Well, I just wanted to do a bit more reflective thinking with you. It's really this incredible effective collaboration across experts and disciplines between organizations and agencies to try and bring this data together. It is the scientists, the experts, the UN agencies, the Insurance Development Forum, the communities who help us to guide us on what we need. I cannot thank you all enough. But we also know that whatever we do in co-creating these tools is that it must be scientifically robust, but also user-friendly. Does it provide what is needed, is it timely, is it appropriate? So what are we doing for the future? I haven't really mentioned this group, but the UNDRR International Science Council Machine Actionability Working Group is working to develop means by encoding these terminologies in line with the FAIR principles, which we know UNESCO has adopted very closely. And so we're very grateful to you for that, Dina. But we want to make the translations easier into every language that's going to be needed and facilitate AI usage. Wouldn't that be exciting? So this is the next step, and we're working on this as we speak, with huge thanks to UNDRR, with huge thanks to the Committee on Data for the International Science Council, but also with incredible thanks to the European Union Disaster Risk Management Knowledge Centre, which I really have been wonderful to work with. But we can only do any of this because we've had the most wonderful steering group, the most wonderful technical logical group members, unbelievable. It's fantastic users, fantastic user group members, multi-hazard context machine actionability group members, incredible contributors to the HIPs. We reach out and say, do you know somebody who knows? And we've had such incredible support. And we put out a call for reviewers of the HIPs, and they were amazing. They spotted things we thought we'd missed, and they really helped us to think about how to do it better. Now, with Helen's support and all our colleagues, we were able to share these at the Global Platform for Disaster Risk Reduction. But I wanted to share this with you too. With Kamal Kishore as the special representative of Antonio Guterres for disaster risk reductions, wonderful help. We launched the HIPs in August, on August the 18th, with Peter Gluckman, the president of the International Science Council, and other great contributors, where we really got the engagement of people talking about the HIPs and knowing they must be used. Do have a look at the video, because the whole of this story is all about using it and having fun with it and accessing it and playing with it on your phone. Do download the QR code because we know it works. And we'd love you to feel this is something you are all part of. You can help us to do better this time, but also make it much better next time. We cannot thank you enough so much for all your help to get us there. So I'm going to stop sharing now.
Thank you very much, Virginia and John, for a great presentation. I think Yasmin will conduct the question and answers. We have
Yes.
an answer question. Well, first of all, we have a few greetings from Gary and from Juan Julio Ordonez Galvez for Virginia and John. The first question is from Bashir Benarfarat. And Bashir, I'm going to open your mic in a minute. If you are able to talk, you can please ask your question yourself, otherwise I will read it. Please unmute yourself. Can you unmute yourself?
While we are waiting for Bashir, can I also send my most cordial gratitude and thanks, Virginia and John? This was an amazing talk. And, throughout I thought how foundational, all your work for our research and for our work. Because I was thinking to myself that, the ability to be able to articulate what we are observing better really brings that cognitive and mental clarity as well. And it's really, really foundational for everything. So I thank you very much. In your person, of course, also, the rest of the team. So it's absolutely amazing work. As Bashir, I think, is unable to join us verbally, I'm going to read the question, please. He says, it is currently observed that efforts to reduce the vulnerability of infrastructures, particularly existing buildings, to risks are progressing at two different paces. The technical and methodological dimensions are advancing significantly faster than the managerial and organizational ones. How can this gap be effectively addressed within the framework of major risk assessment?
Thank you very much, Yasmin. And also thank you, Bashir, for your question. Dina, would you like to think about answering? Do I see you would like to answer this question?
That's very interesting. Yes, I was thinking about it. The way in which the organizational gap and the technical gap are, or the gap between these two strands of the infrastructure resilience are progressing. It's quite interesting because it's not necessarily across the two different disciplines and across the two different, let's say, bodies of actors. It more has to do with the level of technology that we can quickly develop and introduce in new infrastructures, and what are we doing to bring older infrastructures to the same level of safety, security, resilience, and so on. So I think there is an issue of emphasis, and there is also an issue of course, finances and investment that creates this gap. And there is also an issue, going back to what Yasmin was mentioning earlier, there is an issue of how the words and the language shapes the thinking. As typically, let's say, engineers think about infrastructures in terms of a series of components that is brought together, and management thinks about infrastructures in terms of a system that should work, whatever the components are. So these different approaches and level of thinking also finds then conflict in the ways in which we intervene and we improve the infrastructure. So I think both, we need to really sit around the same table as usual and do much of the talking that you have been doing in the past 5 years to get to this point.
So may I add a point, Dina?
Sure.
I think UNESCO is extraordinary. I love the fact you hold together the building codes, which, Yasmin, to me are simply vital for either retrofitting or building buildings safely in the first place. And if I go back in history, we know that Mexico was really distressed when they had terrible earthquakes and some of the hospitals pancaked, which was so shocking for us in the health domain and so worrying. And that taught us so much. But then look at Japan with their incredible retrofitting on buildings that has been so remarkable, as many other countries have done. So to me, it's been a wonderful way forward to try and take together the information and systems that you have. And your UNESCO DRR team are very much at the heart of trying to build those building codes and making them as accessible and useful and usable and used as possible. Bashir, you've asked a great question, but have we helped you in thinking through the answers? Yasmin.
Thank you, Virginia and Dina. Yes, indeed, it was a good question, and some great insight there. Bashir, if you have any follow-up questions, please put them on the question and answer section. I would like to move on to our second question here from Juan Julio Ordóñez Galvez. The question has been posed in Spanish, and I used some web help essentially to translate it, and I'm going to read it out loud, imagining perhaps one is not comfortable with English. He's asking,
Julio, if you want to unmute yourself, you can do so.
Yes. So in English, he's asking, based on what has been shown, we have clearly identified each of the dangers that afflict us socially. But if so, what do we lack to understand their true magnitude in light of the levels of response they leave us with? I don't know how meaningful, in the English language, this question to you, Virginia, and John, if you have any insights, we'd be very happy to hear them.
So Yasmin and Juan Julio, a lovely question too. So in the societal hazards, we currently have 9 hazards, just to share them with you. We obviously have conflict, which can be international or national conflict. which I'm very grateful to ICRC to help us to complete this and to get this through. It's been very difficult thinking it through. We have things like, obviously, as I showed before, environmental degradation from conflict, which is really important, and explosive ordnance. So things like landmines, which are so frightening, and of course such problems. Now, those are not necessarily what you'd fully expect, but we also have things like violence. Violence is in there, Juan Julio, and to us, violence is so important. And in COVID, of course, it was a secondary problem for so many, where gender-based violence, which is just devastating, or child abuse, became such an issue in COVID as a secondary hazard that was really frightening. But violence is something that is really important for us to be aware, and civil unrest is increasingly critical. And civil unrest is obviously something that we do see, sadly, around the world. It's been a very frightening time for all of us lately. The next thing I wanted to share, so we've got those. We also have things like public stampedes, mass gathering stampedes, those sort of things. That's something that we've also been asked to include, and I think that's a really important one. We are just getting through a new bill in the House of Parliament called the Hillsborough Review about the impact of the stampedes we had and the mass gathering issues at one of our football matches many years ago. The other thing we have is suicide clusters. Space and place are really critical, and I'm really glad that we've managed to get that through as a hazard. But what's so interesting, that although we've managed to include that, we know that suicide clusters are very tricky, because it's the only type of mental health impact that we have from disasters as a primary hazard. John's already talked about the secondary hazards, and I'm really pleased he's quoted a couple of the papers I've been privileged enough to write with my colleagues on landslides and the mental health aspects, one with Marcelo from Brazil, and another one from Ian Kennedy, who I worked with when he was one of my registrars. So we know that mental health impacts are absolutely vital. And the final one, of course, we've got something that hurts us all as a societal impact: financial shock. So there's plenty of them there, but there are others that we didn't know whether we should move into the societal hazards, like cyberbullying. Is that something that should be there? Or social phishing, or whatever, some of these really complicated cyber hazards. So there's lots more to discuss. We certainly haven't got all the answers, but I hope you've got an idea of some of the things that we've been looking at as primary hazards, not secondary hazards. So, for instance, one of the secondary hazards that didn't finally cut it was food insecurity in the end. So really important. And I hope that would be helpful for you to think about. So we hope that's
Virginia.
useful.
Thank you, Virginia. And I was thinking both of these last questions actually make your remark on a similar framework for vulnerability very relevant, don't they? Because all of these hazards that we are talking about, especially through the lens of the societal impact, etc., brings that vulnerability element to the forefront. And again, I think there is a lot of overlapping and terms which we use interchangeably, but further clarity, I think, in that domain also would be much welcomed.
Thank you. We would love that, wouldn't we, John? We feel that would be something that would be very worthwhile to do with our many partners. And maybe, Dina, we might talk to you further about it if you should be interested. We think it's something that really matters to be able to try and deal with some of these wider issues we're getting now. Thank you.
Indeed, before we pass to the next question, I think there is something quite fundamental here, because looking through your hazards profiles, you have listed hazards that, as engineers or as technical people, we would consider as consequences rather than, and you have actually looked at it in terms of the parent hazards, the hazards, and then the child hazards. So talking about naming these as hazards rather than damages or consequences then puts completely shifts the way in which we are thinking about it, in terms also of the mitigation that we can bring upon. and in terms of the vulnerability of the recipient of that hazard being a person or an asset or part of the land. So it is quite, it is, let's say, a taxonomy shift, but then it becomes a knowledge shift and an understanding shift, which is very important, I think, for the way in which then we can collectively act to mitigate them. So it's very important. And yes, I mean, the work on the vulnerability would be very interesting. John, maybe you want to...
Yeah, I think part of the question which was asked was about metrication, or kind of quite a comment on metrication.
Yes.
Metrication is really important because one of the reasons we're doing this, unless we can define something, we can't measure it. And unless we can measure it, we can't manage it. And metrication is almost the next step, really, to in many of the and where we go. And in fact, at the moment, it's not clear. A lot of the metrication is not clear. We're all using different measures when you're looking at the same hazard. So, for instance, if you look at say the deaths from from an earthquake, you'll find you've got a wide range of death estimates, and that may be because you've perhaps got multiple events. It's a major earthquake to start with, and several aftershocks. You may have deaths which are caused by secondary hazards, such as a landslide, as opposed to the earthquake itself, or building collapse in the earthquake. You've got a lot of deaths perhaps associated with health problems many years later. How do you measure these? This is a real issue across all of the HIPs, and in fact, one of the things I think we would like to see is much more involvement with the insurance industry, which actually has started to put some boundaries on some of these metrics in a way that we haven't. And I see that in future iterations of the HIPs, this will be something which we'll concentrate on much more.
Thank you very much, John. There is a question from Ali Osman. Ali, again, I will allow you to talk, but then you need to open your mic, please. Also, you appear in two different... Can you open your mic? There is something that doesn't seem to work. I don't know why.
There are two questions in quick succession from Ali.
Yes, so maybe you can read them.
I'll do that. First question is, what are the key engineering and planning measures used to reduce the risk of earthquake-induced landslides in steep and sediment-prone areas? This is probably for you, Joan, and then I can go to the next one, although that's also about landslides. Would you prefer me to read the second one as well?
Let's start with this first one.
Okay.
The key planning measures which we can undertake are surveys of ground, particularly slopes in areas where we've got a lot of infrastructure or populations which are vulnerable. And through examination of the slopes, we can usually determine something of how get an estimate of how hazardous those slopes are. In areas where we are concerned about slopes, the vulnerability of a slope to a trigger such as an earthquake or a hydrological event, major storms, etc., we would advise then that we don't build in those areas. We avoid those areas. Sounds very simple in practice, but of course, in real life, you've got people working and living in areas which are quite dangerous. What we can do, and increasingly doing now, is trying to forecast if there is an earthquake or a major storm, what would the effect of the landslide be, and then therefore we can look at how we might respond to that. Earthquake prediction is still a long way off in terms of reliable prediction. So I think the key thing is planning and engineering associated with the planning to actually try and reduce disaster or the risk of damage in earthquake-prone areas.
Okay, thank you, John. And the second question, I think some of your answer now is going to cater to that as well. Is a bit of a wider one. Considering that landslides can be triggered not only by natural events like earthquakes and rainfall, but also by human activities such as deforestation and construction, what integrated risk management approaches are most effective in reducing multi-causal landslide hazards, especially in urbanizing regions?
Yeah, usually when you talk about looking at things like deforestation and construction, these are contributing factors which increase the risk and increase the often can increase vulnerability in the case of an earthquake. They tend not to cause the earthquake the earthquake themselves. So, well, sorry, the landslide associated with the earthquake itself. So, what again is a bit similar to my answer to the previous question. Is it's planning, which is going to be the main tool which we can use to reduce future landslide risk in such areas. And things like deforestation, changes in land use are very important. And in areas where we have got quite high vulnerabilities, such as in places like Nepal, looking at land use has been something which a lot of organizations have been doing in recent years, so that we can actually minimize risk in such regions.
Thank you, John. Thank you.
I think we can try to go to Gary, if Gary can unmute himself. Yeah, raised his hand a while ago. Gary, can you speak?
Mute.
Yes, good.
Yeah,
we can hear you, please.
Okay, great stuff. I've just typed up a little bit of a statement, really. And good to see you, Dina. Great to see you, Virginia. You know, always very supportive of all the works you're doing. Right. In Nepal, we're targeting it slightly differently, not in competition. I make that very, very, very clear. But we have an issue here that there is a vast unawareness of risk, right? And that goes across all the hazards within Nepal, but also we have nearly 5 million travelers for education, for work in all four corners of the world. And what we're trying to do is overcome and arm them against ignorance of what they might expect in those countries. Now, not only what they might incur themselves, but what might come up in conversation, might come up in media. And of course, you did touch on that earlier, is the psychological anxiety, right? So we have this fake news, and if you are totally ignorant of the issue of the risk, then your tendency is to believe exactly what you're being told immediately and potentially react towards it. So we're working on something which I will share with both of you, all of you, in the future months, which is targeting our sort of secondary school level, not our higher education, right? And simplifying and enabling as much information to get out to our 33,000 schools as quickly as possible, all right, through the Principals Association, which we're implementation agency for. And the reality is that, and we think we can do that very, very quickly. So it's what the information you're giving is amazing and technically perfect, no question about it. But it's very difficult to implement if I'm trying to advise school teachers who are not actually trained as school teachers. but they've been doing the job for several years, and some of them are very good at it, but they're not qualified teachers as you would expect in Europe or America and so on and so forth. So we're having to simplify and make it accessible, and it's not in competition. I really stress that. So that's the comment I'm wanting to bring across. I wasn't going to raise this, but I think it is worth raising, and I look forward to sharing some of this, what we're doing. And we've got what we call a drop-in resource center here, which allows teachers, and we're creating the online platform, allows teachers to gen themselves up with all the different categories of risks, and we are following what your categories are, and allowing them to simplify that into the classroom of 7, 8, 9, 10, 11, 12-year-olds, and really important, generating that awareness, taking the myth out of the subject, but raising the awareness to the seriousness of what they might incur in their travels. Okay, thank you very much.
Thank you very much, Gary. Please, Yasmin.
Might I comment? So first of all, Gary, wonderful to hear from you again. I can remember working with you in 2009 on the Safe Hospitals Programme for WHO.
Yep.
So years of practice and years of collaboration. And thank you for being in touch today. To us, we believe that the hazard information profiles should be useful, usable, and used by everyone, which is why we're very anxious to translate them into local languages, so people can read them in their own language. And we had some wonderful comments from Bangladesh that we needed to be able to turn them into song, so people could sing them, so that they could communicate with them. But let's go back to Typhoon Taklaban, which hit the terrible typhoon that hit the Philippines in 2013. One of the things that people kept on saying was that there was a risk of storm surges, and nobody understood what a storm surge was. They thought they understood what a tsunami was. If we'd used the word tsunami, which it wasn't going to be, then we might have got people away from the shores much faster and really saved their lives much more effectively. So we have to have a common language so we can provide the right advice to the people who need it as soon as we can. And that's what I think we're trying to do with this definitions, to make sure they really are useful for communities. And maybe learn how to sing them. They don't need to know everything, but they might need to know what they need to know so they can share it across with others. And it can be in the right language for the right international tourists that you've certainly had in Nepal, and you've had a lot of very bad cold and snow already, and with a lot of travelers, which has been really awful recently. For you and many colleagues, Gary, I'm sure, in Nepal, and very frightening, but we need to be able to remember that some of the most vulnerable people are inevitably the tourists who don't speak the local language. So they might not understand the main things. So I hope, Gary, that's a useful way of being in touch. And do email me if you have a moment. It'd be lovely to be in contact with you again. So if we can, there's a few other questions we might need to get on to, because we're beginning.
Yes. Juan
Okay.
Julio, again, another question in Spanish. So I again used the web tools. Is it possible, he asks, within this geological dynamic shown that the Earth is in an evolutionary process as part of its own external and internal geodynamics?
My answer to that is yes. The Earth is always moving. Although we all think the Earth is stable, it's not. We're all moving all over in plates slowly all over the globe. And the processes which drive that, and the processes which are caused by that movement, are all very dynamic. Which is why we have earthquakes every day. Why we have many of the geological hazards occurring frequently. So it's wrong to think this is a stable regime we live in, where everything is moving. In relation to how different geological hazards trigger each other, etc., or are triggered by each other, and indeed the other hazards, is something which is quite complicated, which is why we have to look at the multi-hazard frameworks that we're looking at in order to be able to perform better in managing these in the long term. So I think that's my simple answer to that question.
Thank you, John. Next question is from Abbas. If you would be so kind to unmute yourself and I'll pose your question yourself, Abbas.
Hello, can you hear me?
Yes.
Yes, we can hear you, Abbas. Go on.
Good afternoon, and first, thank you for the nice presentation. I mean, especially the multi-hazard context was amazing. And now let me just set the context first. Let's say I want to use your experience to justify my approach to my managers. Now, with this context, could you share some lessons from the development of these HIPs that have helped you better define or navigate the trade-off between this conceptual clarity that you were trying to achieve against operational aspects of DRR. For instance, the time and the money that has been spent on this, bringing this clarity, was well spent with comparison to spending the same money and energy in doing something on the ground to reduce the risk.
Could I
Thank
come in
you.
on that? Yasmin, can I reply?
Yes, please.
Everything that was done for the update 2025 of the UNDRR International Science Council Hazard Information Profiles was voluntary, except for our wonderful project manager. Nobody was paid for this. Although a lot of people did a huge amount of voluntary work to help us do this, because we thought it was something that was really important for the global good, and to help people at local levels to be able to think what the hazards might be. After they have the driver of the hazard and the child of the hazard, there's been a lot of requests that are building the triggered hazards. So if you are in a disaster risk management role and you have a hazard, it's very helpful for you to think about what have others identified in research, in events, in publications that might happen as a consequence of that hazard. And that was what we were trying to do, to try and bring that to you in a way that might be visually quick to determine, and hopefully, when it's translated into local languages, be useful for you to share at every level with your colleagues to see what might happen next that may be important for you to think about and plan for as quickly as you can. I hope this is reassuring to you, and this is why we really have to say thank you to so many for their incredible engagement and contributions to this work, because this is a global effort for what I think is of global good. So I really want to say thank you to all.
Thank you, Virginia. Thank you. Next question.
Can I just say thank you for Abbas for asking that question, because I think you've allowed me to say something that I hope really resonates, and I'm very grateful.
Indeed. Next question is from Omar Flores. Would you like to introduce yourself and tell us a little bit more of your suggestions, which sounds very interesting, Omar?
Let me just unmute. Yes, here you are, allowed. Let's see. You should be able to unmute yourself, Omar. Omar, are you there? Maybe
I'll read it.
Here good. Omar, please introduce yourself, and if you can ask your question.
Okay, I am an engineer working for San Carlos University. I have done some work with Dina and Mrs. Stone about seismic vulnerability at some part of Guatemala City. But now that we are discussing the new classification hazards from United Nations, I saw that here in Latin America, we have many social problems like the gangs, extortions, violence. As if we can read some sensational papers, there are many deaths because of violence and the gangs here that is more than maybe a small landslide. And my question is, why is not included now in this new classification?
So if I could respond, Omar, I will type my answer as well. If you go to the violence hazard, you will see that I can't get enough in there. It hasn't got enough room. So I'm just going to put in the hazard information. Actually, I can't get it all in. Gang-related violence is in there. So do have a look at it. but it's also, if I can give you the online version to have a quick look at, we have tried to include this where we can, if that would be of use to you. I haven't answered it in full, I'm so sorry. But if we could, Yasmin, if you could just send I'm just going to put it into the main chat.
Yes.
Absolutely. Absolutely. So we can always help you to connect with some of the people who ask questions also at a later point. But I'm gonna try and carry your answer to him now, Virginia.
Okay.
Yes, I received it now. Lovely.
Okay, I just think it's so important that you're asking a question that we have been really concerned about, and I wanted to reassure you it is included in balance. It may not be perfectly done, but it's there, and perhaps that's something to make stronger in the future with your help. Thank you for your question.
Yeah, if I can emphasise that the HIPs are not static. We've had a recent iteration. There will be future iterations. We know that there are gaps and there are things which we can improve. We already know that, and I think it's really important that everybody engages in the next iteration of the HIPs to make sure that we get the best product out, the most usable product out, so that we're going to have greatest impact with it. So there are several gaps we know. Make sure that next time around you engage in the conversations, and we can do something about addressing those.
Thank you.
Indeed.
Yes.
There is one more question on our chat channel from Penny with a similar question, actually. Penny, would you like to introduce yourself and ask your question?
Yes, of course. Thank you very much. And
hello.
Really, hi, very interesting to see this work, and more amazing that what you said, Virginia, about all of this not being paid. It's amazing. My name is Penny. I'm Sustainable Finance Advisor. So I'm looking at this work from climate resilience and adaptation perspective. So the question I had was whether, in the same way that you have used degradation from conflict as one of the hazards, whether in the future it will be possible to have another hazards that will show degradation from climate change. Thank you.
So, Penny, you've asked a question that inevitably, because of the Paris Agreement, has been at the heart of some of our discussions. When we were looking at, it's such an important question, when we were looking at whether climate change should be a hazard, we asked the World Meteorological Organization, we asked the Intergovernmental Programme on Climate Change, we asked the UN Environment Programme, we asked everybody, and they all said, no.
No.
It's a driver of hazards. It is not a primary hazard. You can't have it. So what we know is that a lot of these hazards can be climate related, can be climate driven, but it's not the hazard itself. And I just think we really went through quite a painful time trying to understand this, and I thought it'd be very important for you to be aware of that. So I hope that that is useful for you to be aware of. And the other thing I wanted to add that I thought would be so important is that in our discussions with the International Telecommunications Union, we've asked about things like AI. And what's been agreed is that AI could be good, or it could be a driver. So at the moment, we haven't included it as a hazard because it's not, because it can help a lot of people, but it also can be an issue. So I just thought it would be really important to share that with you. But Penny, what a great question. And we've really tried to think it through and see if we can understand it better. Thank you.
It's really pleasing to see questions that actually prompt all the highlights that you intend, right? Or you think important, Virginia. Great. So we have finished all the questions on the question and answer channel. Are there any questions from the audience? Dina has just put some further information on the gang-related violence, I think using exactly. Okay, Virginia's link, Dina, there. Thank you so much for sharing that. Omar, I am hoping that you can see it.
Yes. Good.
Lovely. Thank you. Virginia, John, thanks ever so much for accepting our invitation. You are absolutely amazing. You know, you are two dear friends and very long-lasting colleagues. We are very happy to host you today. And it was I really think that it was a very foundational topic, and it's gonna, you know, it's gonna change how we work. Like, I think everyone around the table today is going to go and refer to the documents that you have shown quite intensely from now on. And yeah, we are looking forward to the next updates and next episodes on this. Thank you so much. I am really looking forward to catching up with you both at a later point. But thank you very much for joining us today, and everyone.
Thank you
Lovely.
so much, Yasmin. Thank you. It's been amazing. Dina, it's been lovely. It's so lovely seeing you and catching up with you.
Thank you, and thank you to all our audience, and
yes,
look forward to see you in a few weeks' times again. But thank you also for everybody that participated in the discussion. The questions are always a very important element of our webinars. Thank you.
Indeed. Bye, everyone. Bye.
Bye-bye.
Goodbye.
bye, Omar.